Hi, welcome back. Somebody sent me a question that I want to do fast. Okay, it's based off of Newton's second law. Now, this question reads as follows: crate P of mass 1,25 kilograms is connected to another crate Q of mass 2 kilograms by a light inextensible string. The two crates are placed on a rough horizontal surface, meaning there is friction. Okay, a constant force of magnitude 7,5 newtons at an angle, this is the force, at an angle theta to the horizontal is applied on Q as shown in the diagram below. The crates accelerate at 0,1 meters per second to the right. Crate P experiences a constant frictional force of 1,8 newtons and crate Q experiences a constant frictional force of 2,2 newtons. Now, would you like to pause and try the question on your own? Okay, now I assume that you have paused and attempted the question on your own. Now, question 1 is a definition, which is why I've written it over here. Okay, it says when a net force is applied on an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the net force and inversely proportional to the mass of the object. Right? Now, question 2.2 says draw a labeled free body diagram for crate P. Right? This is crate P, so I'll just increase the size here. So this is crate P, and number 1 we have FG. Right? We also have the normal force. Okay, we have friction on going to the right, the left, and then we have the tension, and then you get your 4 marks. Right? Now question 2.3.1 says calculate the magnitude of the tension in the string. Right? It's question 2.3.1. the magnitude of the tension in the string. Okay, we are going to be using these forces over here on the horizontal, so we can use the formula F net okay, I'll just use a different color, equals to MA. Right? This is Newton's second law, and we know that in the horizontal we can say tension minus the frictional force equals to the mass times the acceleration. Do we know tension? No, it is what we're looking for. Minus friction is 1,8 newtons. Okay, is equal to the mass is 1,25 times the acceleration, which is 0,1 meters per second. Right? I'm going to isolate tension. We have 1,25 times 0,1 plus 1,8, and when you punch this into your calculator, you should get 1,93 newtons. Right? You can also say right. Did they say magnitude? Or okay, they said the magnitude, so you're not supposed to include the direction. Right? Now they're saying calculate angle theta. This is your angle theta. Right? So before we calculate angle theta, we can draw a little free body diagram for crate Q. Right? This is your crate. You have your gravity Fg. Right? You have your normal force as always, and then you have this force over here. this is the force applied, and then you have tension as well as friction. Yes, we do have friction. It's 2,2 newtons. Now we can resolve Fa into its components, right? Now this component over here, okay, we have theta over here, so this component is supposed to be Fa cos theta, right? And the vertical component is supposed to be Fa sine theta, right? So we can calculate this angle over here since we have the force applied, right? We'll just use Fa cos theta and these forces over here, so we can say F net equals to Ma, where our net force is going to be the tension. It's going to be Fa cos theta minus tension minus Fk. Now we just sub in some values, right? Fa is 7,5 newtons. Jesus cos theta minus tension was 9,193 minus friction is 2,2 is equal to, what is our mass? Our mass is 2 kg, right, times 0,1, which is our acceleration. Now we can take all of this to the other side. We get 7,5 cos theta equals to 2 times 0,1 plus, I'll just add these values together. Plus 4,13, and then I'll just add all of these to simplify. Which is equal to 4,33, right? And we can divide both sides by 7,5. And I'll just leave it like that. Now we have cos theta equals to 4,33 over 7,5, and then theta is supposed to be the arc cos of 4,33 over 7,5. And then when you punch this into your calculator, you get theta is 54,74 degrees, and this is your final answer. And you can confirm this by looking at this angle. It is not greater than 90 degrees, right? So yeah,